Hello guys, welcome back to my channel. Today we have Umar Hafiz, Mustaqir Rahim and Ikhwan Zurinian. Today we're gonna discuss about two tests. That is Z test and T test. Let's go.
This flowchart details the rulebook for selecting the correct test. The first decision node identifies your data groups. You contrast distinct groups using a two-sample test, while tracking the same group requires a paired test. The second node checks sample size. Analysts default to the t-test for smaller samples, reserving the z-test for large samples. This diagram illustrates the two opposing rules of the game. The null hypothesis, or H0, assumes no difference exists. The alternative hypothesis, H1, claims a definitive difference. To officially declare an alternative difference real, we require a strict 95% certainty level, known as an alpha of 0.05. This sets a high bar for evidence. This image outlines a working scenario featuring two slightly different data groups. Because the sample size for both Group A and Group B is 25, the rules dictate we use a two-sample t-test. This formula deconstructs the logic of the test into a simple ratio. We divide the raw difference between the groups, the gap, by the natural variation of the sample sizes, combined into the noise. This graphic reveals the mathematical result of running this specific data through the formula. The process outputs a calculated t-score of 1.95. This calculated score is the single metric that determines if the signal is loud enough to overcome the background noise. This chart displays the critical threshold. To achieve our required 95% confidence, our score must cross this strict numerical boundary, set here at 2.06. When we map our working example onto this landscape, our calculated 1.95 falls short. Failing to cross this mathematical boundary means the data does not possess enough statistical gravity to prove the groups are actually different. This image shows the formal, rigid statistical verdict based on the threshold failure. We failed to reject the null hypothesis. This graphic translates that formal ruling into plain English. Despite observing a superficial 5-point gap in the raw averages, that gap is statistically meaningless and likely caused by random chance. The ultimate takeaway is clear. Never execute strategy based on raw, superficial data differences without first verifying them through the appropriate statistical threshold.
So for the first case, we want to know if there is a significant difference in academic performance. So we compare engineering student with business student at a 0.05 significant level. So for the first step, state the hypothesis. And then for the second step, we find Z value, as we already know that we use Z test for this case. And then for the third step, we find critical value. We need to divide by 2 because this is two-tailed test. And then for the step 4, we need to determine whether to accept or reject H0 value. For the last step, we conclude. So in this case, there are significant difference between business and engineering student.
Okay, now let's move on to question 2. For the step 1, state the hypothesis. For the second step, we use the Z formula to compare the two sample means. And now, we substitute the values. After calculating, we get Z equal to 2.06. For step 3, find the critical value. From the Z table, the critical values are plus minus 2.58. Okay, now we have to make the decision. Our calculated Z equals to 2.06. This value is between negative 2.58 and positive 2.58, so it falls in the non-critical region. So we gonna set H0 at 0.01 significant level. And for the last step, we conclude there is no difference between low-carb diet and plant-based diet.
First, we state the hypothesis and determine whether the test is one-tailed or two-tailed. Since the question asks whether remote research are more productive than office research, this is a one-tailed test, especially is a right tail. Next, we use the z-test. After substituting all the given value into the formula, we get the calculated z value of 1.36. Then we compare it with the critical value. Since this is a right tail test at the 0.05 significant level, the critical value is 1.65. Because 1.36 is less than 1.65, it does not fall in the rejection region. Therefore, we fail to reject the null hypothesis. In conclusion, there is not enough evidence to show that remote research are significantly more productive than official research.
Okay, next up we have question number 4. For this question, we are using paired sample t-test because we are comparing blood pressure of the same patient before and after taking the herbal supplement. Okay, so for the first step, we are finding our mean and standard deviation using the formula given. Next step, using T formula, we are construct the value to find the value of T. Step 3, at a significant level of 0.05. Since it's two-tailed, we need to divide by 2. And finding our DF value so that we could find our T value and construct a graph. After constructing a graph, we found that our T value falls in non-critical region. So we need to accept H0 at significant level of 0.05. So in conclusion, it is successfully proven that herbal supplement help the patient reduce their blood pressure.
That's all from us. Thank you. Got it.